Welcome to Legacy Chiller Systems. My name is Dwayne Ribbley. I'm with the Process Engineering Department. This short video is about the air-cooled refrigeration cycle. We're going to be going over how the chiller will take processed water and transfer heat over to the refrigerant side and reject it out to the air. Let's take a look at an air-cooled chiller refrigeration diagram. There's a video that I posted called the process water side of a chiller. And in that video, I stated a piece of equipment will generate heat. The heat will be transferred to the water, and that water or water glycol will come directly to the chiller evaporator, which is this piece right here. What the chiller evaporator is where the process water side and the refrigerant side meet, and the heat is transferred. How that works is through the second law of thermodynamics. The second law of thermodynamics states a hotter source will always move towards a colder source. So the refrigerant has to be colder than your desired leaving water temperature. So you got your warm fluid coming into the chiller evaporator. The heat is transferred over to the refrigerant side. Then you will have your desired leaving water temperature back to your process. Go take a look at that video and you'll get a little bit better in-depth explanation. So let's get back to our refrigerant side here. The heat has been transferred from the water side to the refrigerant, and at this point, it's going to be a low pressure gas. It's going to travel its way to the compressor, and what will happen there inside the compressor is it will take that low pressure gas and compress it into a high pressure gas. That's all really a compressor does. After it's been compressed, it will leave that compressor and go to the air-cooled condensers here. Now, this is what makes an air-cooled chiller different from a water-cooled. What will happen is the air will suck through the sides of the condensers and it will blow out through fans out to the atmosphere. How that works is through the second law of thermodynamics. That compressor is going to take that low-pressure gas and compress it to a high-pressure gas. That temperature of that high pressure gas could be 180, 190, 200 degrees. It really just depends on the refrigerant that you use. So you have 190 degree hot gas and you have 95 degrees outside. So that heat will want to transfer out to the atmosphere and go towards that colder 95 degrees. And that's how the heat is removed from an air-cooled chiller. After it leaves the condenser, it's going to have a state change back to a high-pressure liquid. That high-pressure liquid will travel through the filter dryer, sight glass, to the solenoid valve, and it will go to the thermal expansion valve, and it will basically have a pressure drop from a high-pressure liquid to a low-pressure liquid. And then it's going to go back to the evaporator, and that whole process will repeat itself. I want to go over a couple quick things about an air-cooled chiller you might want to know. There is minimal maintenance on an air-cooled chiller. On the condenser side, as long as you keep those coils clean and you keep your fan motors running, there isn't much maintenance compared to a water-cooled chiller. There does need to be more space for the heat to be rejected to on an air-cooled chiller. Air-cooled chillers typically go outdoors. If you put them indoors, you want to make sure it's in a well-ventilated room. If you put it into a confined space, the heat will not be rejected and your refrigeration cycle will basically shut down and your piece of equipment will not get cooled. There is less installation in an air-cooled chiller because they stand alone. They don't need a cooling tower or building water like a water-cooled chiller does. They are bigger in size compared to a water-cooled chiller because those condensers and fans are much larger than the condensers on a water-cooled chiller. They are more common because they do stand alone. My name is Dwayne Ribbley. I'm with Legacy Chiller Systems. Come take a look at us on Facebook. We have a YouTube page full of great videos. And we have our Oracle Economizer technology patent that we have where we are reducing the kWh on any brand chiller, any size, up to 50%. Feel free to call my office at 877-988-5464, extension 106, if you have any questions about chillers or you need any kind of chiller design assistance on any projects. Thank you.